Hello, my darlings. Today we are going to be working on the third method for solving systems of equations. So remember the first method we learned, just a quick review, is to graph them. There can be one solution, no solutions, or infinitely many. The second way we learned was substitution. When you solve one of the equations for a letter, take what it is equal to and substitute it into the other equation to solve. Now we're going to look at elimination. When I was in school, substitution was my favorite method, and I think it's because my teacher emphasized that one the most. But as I've started teaching this, elimination has actually become my favorite method, and I think it's easier for most students. So I hope you really like this method. Elimination is exactly what it sounds like. You're going to eliminate one of the variables so that you only have one left, and then you can solve for that variable. So there are a few steps to elimination that you've got to check ahead of time. First, you got to make sure that all of the matching or the like terms are in a column. So here, my x's are in a column, my y's are in a column, the equal signs need to be in a column, and the constants need to be in a column. If for some reason, when you start the problem, they are not in a column together, you need to rearrange the equation so that they are in a column. I will say that most of the time when it's easiest to use elimination, they're already in that order. If it's in a different order, it may be easier to solve by graphing or by substitution. So first, make sure that they're in a column. Second, you need to see if there is a variable that has matching coefficients, and I'll tell you what I mean by that in just a moment. If there's not a variable with matching coefficients, then you'll do what we're going to learn tomorrow. Today, all of ours are going to have matching coefficients. So when I look at this one, the x has a coefficient of 1 and 1. The y has a coefficient of 1 and -1. You do not have to have matching for both letters. And when I say matching, I mean the same number. They might be opposite signs, but the same number. You actually would like it if they were opposite signs. So I'm going to change color markers to show you this is the problem. Now we are on page 12 in your packet. So pause the video if you need to turn there. I am actually doing a problem from page 13. So what you do once you realize that they are in columns and you do have a matching set, if that matching set has opposite signs, meaning one of them is positive and one of them is negative, then you can add. So I am going to go with the y's because it's a lot easier to add. So I'm going to add the two equations in columns. So x plus x is 2x, and y plus -y is 0. We bring down the equal sign. -4 plus 2 is -2. Now we have a one-step equation. So we take that one-step equation and we solve it. Divide both sides by 2, and x equals -1. So we have already figured out half of the ordered pair. Then to figure out the other half, you're going to take what x is equal to and substitute it into either equation. I'll just go with the top one. So it says x plus y equals -4. So I'm going to put -1 for x and solve for y. So I would add 1 to both sides and get y equals -3. So my answer is -1, -3. And that's it. That's all you got to do. Pretty simple. So you are trying to eliminate a variable by adding them or subtracting them. And you always want to add them if at all possible because we're better at adding than we are subtracting. Some books teach you to never subtract, to always make it so that they are opposite. And when we get to a subtraction one, I'm going to show you both ways. But let's look at number 2 from the same page. 2x minus 3y equals 14, and x plus 3y equals -11. So again, we make sure they're in columns. X is in a column, y is in a column, equal signs in a column, constants are in a column. Next, we check and see, is there a letter that has matching coefficients? So when I look at the x, one of them has a 2 and one of them has a 1. That is not a match. So I look at the y. One has a -3 and one has a +3. That is a match. They're opposite signs, but it's still the same number if we took the absolute value. So we're trying to get rid of the y. So if they're opposite signs, we're going to add to get rid of them. So I'm going to add here. 2x plus 1x is 3x, and -3y plus +3y goes away, and 14 plus -11 is 3. Divide both sides by 3, and we get x equals 1. Now, I want to point out two things. One, you won't always be getting rid of the y. Sometimes you'll be getting rid of the x. It just so happens for these two examples, we got rid of the y. Second, the answer will not always have a 1 in it. Again, it just so happens that both of these do. So then I take either one of these. I'm going to go with the first one. 2x minus 3y equals 14. But instead of x, I'm going to put what x is equal to, which in this case is 1. So 2 times 1 is 2. Subtract 2 from both sides. I get -3y equals 12. Divide both sides by -3, and I get y equals -4. So the answer is 1, -4. All right, I'm going to stop the video here because I don't like for them to be super long. There is going to be a second video where we look at some with subtraction.